this. Hello, everybody, and welcome to Math with Mr. Taco today on Monday. Today we are reviewing decimals and place value. You're going to need something to write on and something to write with, and here are the I cans. I can explain how zeros act as placeholders for the absence of value in a given place. That sounds very complicated. It's not as complicated as you think. We'll go over it. And also, I can accurately set up vertical form for addition and add numbers that contain decimals. Now, as we've been discussing decimals, or being able to show fractions or equal parts of a whole unit in our base 10 place value system, I thought it was important to kind of go back and think about the purpose of the zero. Because in my hand, you can clearly see here there are 0 pencils, there are 0 alligators, there are 0 space shuttles, right? 0 isn't so much a number as the absence of a number. 0 isn't so much a value in itself as the absence of a value. Okay, you always have 0 of anything you can think of. Sometimes you have more than 0 because you have some of it, right? I have more than 0 dry erase markers in my hand, for instance. And when we look at our place value system, I've got right now just the thousands through the thousandths up here with our decimal point in the middle. We want to think about this 0 as a way to hold our place if we don't have any value in a given place, but we still need to keep track and know that that place exists, right? If we had, let's say we were dealing with, I don't know, dry erase markers. And let's say our dry erase markers came in a box of 100. Okay, they come in boxes of 100. And we have 2 boxes of 100 dry erase markers. We also have 6 kind of extra markers that maybe we had left over from last year, something like that. So in that case, we would say, we have 2 boxes of 100, so 2 goes in the hundreds place. We have 6 extras. We have 6 ones, 6 individual markers. Do we have any groups of 10? No, we don't have any groups of 10. But we can't just leave it blank, because otherwise it'll end up looking like 26, which is much different than our value, right? So that's where our 0 comes in. It holds the place and says, well, we don't have anything in the tens, but in order to make sure our hundreds are clear as hundreds and our ones are clear as ones, we're going to put a 0 in the tens place. Now, what about all these extra places? There are also zeros here, because we don't have any tenths of a marker or hundredths of a marker. We don't have any boxes of 1,000 markers, okay? All the way till the cows come home on that side, all the way till the cows come home on this side, there's zeros all the way down, because all it means is there's no value there. Now, it would be a little tedious to write an infinite number of zeros in both directions for every single number we're trying to show, right? And these numbers, because there isn't anything larger than the hundreds, there isn't anything smaller than the ones, this is why we don't have to write those zeros, because they're not holding a place for anything, because we don't have any value in any of those places to the right or to the left of the thousands place. So all we need to write are these 3 digits, and we need the 0 in the tens place because there's value in the hundreds. Okay, if there wasn't any value in the hundreds, let's say we only had our 6 markers, would we have to write this 0 in the tens? No, because all we have are 6. Okay, this is no longer holding the place for anything because we don't have any value, period, that way. So all we would have is 6. But the idea is, when and we'll get to sort of the adding of it all, if there kind of is an absence or we don't have that place shown, there's always a 0 there we can use, okay? So 6, let's say I was trying to add 6 plus 18 hundredths. okay? And this is where I see a lot of people getting in trouble of going, okay, well, I have my 6, and I have my, do I do this? Do I do, where's my eraser? Do I put it here? Where do I put it, right? So this is where it comes back to, we always have to know where that decimal place is, okay? Because that decimal place is kind of our demarcation line. It's where whole numbers end and fractions begin. And it's always going to be to the right of the ones place and to the left of the tenths place. So with any whole number, okay, be it 6, be it 206 from earlier, be it 15,206, right? Our decimal point is always going to live right here between the ones and the tenths place. And because it's a whole number, there's zeros in the decimals all the way down till the cows come home. But that's where the decimal point is just to the right of the ones place. And when we add, let's say whole numbers with decimals, or whole numbers and decimals with decimals, okay, it's important to be able to represent and show the decimal place and use our zeros to fill in the gaps. Okay, so let's try it with one on our digital whiteboard. So we have here, here is our task. We're doing 172 plus 6/10 plus 8 plus 93 hundredths. And our goal is to line this up in vertical form, so stacking them up on top of each other, and then be able to add them accurately. And in order to do that, we have to be able to know where is our decimal point, because that's going to be kind of our key to lining everything up, because we have some decimals and we have some whole numbers. Okay, so let's start with our decimals. Okay, let's start with our 6/10 and our 93 hundredths, because that's gonna, those both already have the decimal point written in there for us. Okay, 6/10 and 93 hundredths. Do you see how our decimal place is, I'll do it in pink here, always lined up in the same spot? That helps us line up our tenths and our hundredths and eventually our whole numbers, okay? Now, I'm noticing this 3 is just kind of hanging out there all by its lonesome, okay? Because our 6/10 doesn't have anything in the hundredths place. So what are we going to do here? We're going to put a 0 in. There's always a 0 there. If there's an absence of a value, you can use a 0 as a placeholder. Okay, just to make sure our, our places are lined up correctly. Now let's take a look at our whole numbers. And remembering, let's take our 8 first. Okay, 8 is in the ones place, and as we remember, the decimal point is always to the right of our ones place. Okay, it's always right there next to it with no other places in between. And that means we have 2 zeros to put in here. We're not changing the value by adding these zeros. Okay, we're not making 8 into 800. The reason for that is that decimal point there. Okay, that decimal point is holding that 8 in the ones place. Okay, if we just had 8 and then we added a 0 next to it, now we've turned it into 80. Because essentially what we did is we took that decimal point and we shifted it from here, and we made it 80, now it's here. Okay, but because our decimal point is staying exactly where it is, which means this 8 is fixed in the ones place, we can add as many zeros as we want on the decimal side, and it doesn't change the value of our number. Lastly, let's look at our 172, and where does this go in our vertical stack here, right? So 172, whole number, okay? So here's our 2 in the ones place, and our decimal point's going to go right next to it with some zeros, okay? And then we can add our 7 in the tens and our 1 in the hundreds, still keeping everything lined up just like we would be if we were adding whole numbers. If I asked you to do 172 plus 8, you'd go, oh yeah, I can do that, right? But it's the decimal point that throws us because it's kind of the new concept. But really, when we get down to it, the concept stays the same of line up each place, stack up each place on top of that same value place. So your ones always go on top of the ones. Tens always go on top of the tens. Likewise with decimals. Tenths always go on top of tenths. Hundredths always go on top of hundredths, etc. Now, oops, I'm going to go keep my blue here. Now that we've got them stacked up, let's add them, starting with your place of the smallest value, just like you would when adding whole numbers. So start in the hundredths place. 0 plus 0 plus 3 plus 0, well, that's just 3 in the hundredths. Okay. 6 plus 9, or 6 plus 10 minus 1, 16 minus 1 is 15. And what do we do when we have a group of 10 or more? We regroup it to the next place. You can and you should regroup across the decimal point, right? 10 tenths equals 1. So I keep my 5 extra tenths here, and I've regrouped my 10 tenths across into a 1. Now 1 plus 8 plus 2, or 9 plus 2, is 11. You see what I did there? Decimal point stays exactly where it is. Regroup my 10 to the tens place. 1 10 plus 7 tens is 8 tens, and then 100. Okay, and if we wanted to really get meta with our zeros, right? There's zeros here too. Right? We don't have to write them because they're not holding the place for any value, but they are there. And if it makes life easier to write them all in, absolutely do it, right? If this makes the most sense to you, go, oh, anywhere where there's not a digit, put a 0, okay? To make sure you know that everything's lined up. If our decimal point is lined up, that's going to give us an accurate result, which in this case is 181 and 53 hundredths. So, your job on the exit ticket is to go ahead and try this, okay? Goes without saying, but you should be doing this on paper or a whiteboard or showing your work somehow, okay? Mental math for this, it's doable, but we've had limited practice with adding decimals kind of in isolation like this. So it's best practice, start on paper, and the more and more comfortable you get with it, then we'll go to mental math strategies. Okay, but always start on paper, always start showing your work by writing it down in some fashion. Okay, thank you everybody for tuning in. Have a wonderful rest of the morning. You've got another history YouTube video coming up in just a little bit. And yeah, have a great day. And I will see y'all tomorrow in person. Well, not in person, but in virtual person.